All right, welcome back to polygons and quadrilaterals. We are going to look at parallelograms and rectangles specifically today. And let's go ahead and dive in. So quadrilaterals, of course, at this point we should remember is going to have, it's going to be a two-dimensional shape. And of course, it has four straight sides and of course, four corners, because if you have four sides, you can have four corners. And we have here several examples of a few different types of quadrilaterals. And we even have one here that's concave, where we have our side that is caved into this object. All right, so let's talk specifically about parallelograms. So in a parallelogram, of course, we know that it's going to be a quadrilateral because that's going to be the first priority. And you'll notice we have several if-then statements here. So if a quadrilateral is a parallelogram, then its opposite sides are parallel. So that would tell me that our side FG here is going to be parallel to the side JH. FJ is going to be parallel to GH. And we want to make sure we're able to make these markings and also identify those markings. So we also should be able to state that if a quadrilateral is a parallelogram, then its sides opposite are going to be congruent. So that would tell me that FG is going to be congruent to JH, and FJ is going to be congruent to GH. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Now, opposite angles are across from one another, so we would have, for instance, the angle F is going to be congruent to the angle H, and the angle J is going to be congruent to the angle G. So again, notice how we are separating out these things. Also within a parallelogram, we should at this point be able to determine that if we have four sides, then we could use our formula from our previous lesson, which was dealing with our angles. So we have a four-sided figure, so 100, our number of sides, 4 minus 2 times 180, and that would give us a total of 360 degrees for our total sum of our angles of a quadrilateral. So another point we can make, other than the fact that these are also going to be congruent, opposite angles are congruent, we can also look at our angles that are consecutive to each other, and that is going to apply here with the consecutive angles being supplementary. So therefore, again, we could determine that, for instance, angle F plus angle J would equal 180 degrees. Those would be our consecutive. The same thing would occur if we are looking at, for instance, JH. Is also equal to 180 degrees. Okay, so that's another one of those properties that we can keep in mind that will help us solve for different problems. All right, so now, if a quadrilateral is a parallelogram, then the diagonals are going to bisect each other. So for instance, if we have our diagonals drawn here, so from the, let's see, so let's try and draw this. There we go. Not very straight, but it's close enough. All right, so we're going to state that we are meeting here at X. All right, so again, if the diagonals bisect each other, remember this is where we have two parts congruent on each side. And here we go. All right, so we can state that Fx is going to be congruent to XH, and JX is going to be congruent to XG. So again, they're bisecting each other. Okay, they're not congruent, but they are bisecting each other. All right, and also, if a quadrilateral is a parallelogram, then each of the diagonals separates the parallelogram into congruent triangles. Which, if you can think about it, that would make sense because, again, we can identify, just drawing here or here, we have congruent triangles. All right, coordinate geometry. Now we get to prove that we have a parallelogram. All right, so now we have the point A being 0, -4. So 1, 2, 4. So here is our point A. Then we have the point B, -6, 1. And -6, +1. That's B. C is 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, and 7. So that's T. And then 9, 2. Oops. 9 and 2. Okay. 2. All right, there we go. That's better. All right, so far it looks like we could have a parallelogram, but we do need to prove it with our math. All right, so we need to again remember what defines a parallelogram. So we want to use the slope formula here. And if you'll recall, the slope formula is m is y2 minus y1 over x2 minus x1. And we're going to need to check each of our segments to see if we actually have parallel segments. So let's do that very quickly. All right, so let's first check the point or the segment AB, which A is 0, -4, and of course B is -6, 1. And again, using our slope formula, y2 minus a -4, which is our y1, over x2. And for this one, again, don't forget your double negative, so we get 5 over a -6. Let's check our segment. Now that's the segment AB here. We've got 5, -6 for slope. We'll do the same thing for CD. All right, so C is 3, 7, and D is 9, 2. And again, checking our slope. 2 minus 7, and 9 minus 3. So again, we end up with a -5 over 6. And as we can see here, that AB is parallel to CD. So far, so good for that set. So these two are parallel. All right, so let's go ahead and now check our segment BC and AD. -6, 1. Oops. C. There we go. Okay, so again, we're going to check that. -1, 3 plus 6, and we get 6 over 9, which simplifies to 2/3. Sounds good. All right, so now let's check AD. Again, watch that double negative. All right, so we have now determined that BC is also parallel to AD. And we could also go and check our distance, which we'll do for our next sample. So we have now proven that we have two opposite sides that are parallel to one another. So therefore, based on the definition of a parallelogram, we have a parallelogram.